Okay, it's that time, so we just will hit the ground running. So we'd started off last Thursday actually with an example similar to this. Kind of left you on your own with it. Let's kind of go through it here so you can see what steps have to be taken. So what I'm going to do with any isosceles triangle usually is divide it in half. And I know that when I run that altitude from that vertex to the opposite side, as long as that's the vertex between the two equal sides, that forms that altitude, that right angle, cuts the angle in half up here, and cuts this side in half. It'll be 50 and 50. Good. Now, let's talk about that angle right there. We have this 5 to 2 slope factor. If I draw a triangle over here, which number goes on the vertical, the 5 or the 2? The 5. The 2 is the horizontal. So this angle right here, which is this angle here, is an inverse tangent of 5 over 2. Giving us 68.20 degrees. Of course, this is also 68.20 degrees, making this angle right here 21.80 degrees, making this angle right here 21.80 degrees, and this one 21.80 degrees. No, it's flat. This is flat. So now, if I cut this across here, that length is not 15. 15 stops somewhere short of that. But I do have a right triangle there. Let's look up here and see what we have. I'm going to draw in a right triangle here somewhere. Trying to decide exactly how I want to draw it. We'll just do it like that for now. I just want to find this angle. How do I find that angle? The 1 over 4. Very good. So I've got 1 and 4. That angle is an inverse tangent. What is it? 14.04 degrees sounds good to me. What that'll tell me is that angle in there. They've got the 21.80, the 14.04 adds up to 35.84. The three of them together add up to 90 degrees, so we subtract that from 90 is 54.16 degrees. What do you think so far? Doing okay? Okay. So then, we have this arc of a circle here. We'll have a right angle on both sides because that is a radius to a tangent. We need to know some things about that arc of a circle. So let's draw that out bigger so we can play with it. We know this is 15 millimeters on each side. Do we know that angle? The answer is, yeah, we do kind of know that angle. we know, trying to figure exactly how to draw this out. We know that this angle right here, well, let's do this. I know this angle right here is the 68.20, right? Which makes this angle over here 111.80. I'm going to draw that out a little larger so you can see what's going on there. This is the 68.20, which is just the complement of this one, because that's a right triangle. That makes this here 111.80. If that's 111.80, this is 90 degrees here. Somewhere up here we had that 54.16. This angle has to be what? A four-sided figure has to have an angle sum of 360 degrees. Yep, 104.04, you are correct. So it's 104.04 degrees, making this angle here 85.96 degrees. $75.96. So this must have been 114. You're right, it is 75 though. Yep, I just subtracted wrong. So 75.96. Degrees. So we have that angle. We can find some things here. Let's drop that right angle down there. We know that's the right angle because that's a vertical dimension that we're putting in. This is horizontal. We can find, I'm going to call this side A and side B. Side A is the opposite side. Opposite and hypotenuse are sine. So sine of 75.96 degrees equals A over 15. Remember, sine is opposite over hypotenuse. So we're going to cross multiply. Sine of 75.96 times 15. 14.55. So this is 14.55 millimeters. B is going to be from the cosine, because that is the adjacent side. So it'll be cosine 75.96. Make sure you close the parentheses, times 15 divided by 1. Yeah, I got 155. Let me try again. 3.64 is correct. So that's 3.64 millimeters, which makes this over here 11.36 millimeters. So let's find the overall height right here. How am I going to find that overall height? You're making it more difficult than you have to. It's a 5 to 2 ratio over 50. Cross multiply and divide is 125. So now this tells me where I need my right triangle up here. I'm going to put it right there. So I have that triangle there. It looks like this, has a hypotenuse of x. An angle here, what was that, 54.16. I'm going to call this over here, well, let's just do it. I'm going to call it D for now. But we know that sine of 54.16 equals D over X. If I solve that for D, I cross multiply sine of 54.16, which is 0.81. We're going to call it 0.811. So D is equal to 0.811 times X, because it'd be that sine times X divided by 1. So this is 0.811X. As I look at my total height here now, I have that piece there that I just found. I have this piece here that I calculated, and I have Y. So this calculated height was 14.55. And then there's Y down here. So I have Y plus 14.55 plus 0.811x has to equal that total height of 125. I know that has to be true. Now, back up here. This piece plus this piece here has to add up to the 50. So let's find that piece. So I'm going to call this F up here. F has to do with the cosine. Cosine of 54.16 degrees equals F over X. We do the same sort of thing, cosine of 54.16. 5.86 or 0.586 X equals F. That plus, it was this distance here, 11.36. Can't add that together because it's 0.586x. But that does have to add up to half of the bottom, which is 50. So now I can solve for x and y. I can solve this one for x. How do I solve this one for x? Subtract 11.36. 0.586x equals 38.64, and then divide by 0.586. $65.94, yeah. Millimeters is x. Then to find y, we've got this one up here. Y plus 14.55 plus, now what I'm going to do is I'm going to take that 0.811 times the 65. So times 0.811 gives me 53.48. Equals 125. So I combine those two, y plus 68.03 equals 125. Subtract 68.03. Y equals 56.97. What do you think? We've got x and y. Not so bad. Well, the good news is it's recorded. So you can replay it over and over and over again. Okay, well, we'll leave that one there. If we need to go over it again at some other point, we will. Back to the circles, Robinson. Those are tangents, yes. Find that overall height, x. I'll give you guys a couple minutes. We have seen ones like this before. Let's see if you're heading in the right direction here. So, we draw those in at right angles. I am going to sketch this in here just so that I have the right angles there and I can find this angle there is off of the 1, 5, right? That's going to be the inverse tangent of 1 over 5. $11.31. 11.31 degrees on each of those. So that makes that whole angle here 101.31 degrees. So this is a 5-sided figure, which means the angle sum is 540 degrees. You guys remember where I get the 540? 3 times 180, where does the 3 come from? 5 sides minus 2 is the number of sides minus 2 times 180. So I've got 90 and 90 here, so I'm going to subtract 180, that's 360. Then I've got 101.31 and 101.31. So I subtract that 202.62 to get 157.38 degrees, correct? So that's 157.38 up there. Now we can cut this thing up a little bit. I'm going to cut this across here, down here. That makes this angle here, of course, this is 50 on this hypotenuse. That makes this angle up here, actually. I'm going to redraw that triangle. This being my 50 millimeters. This angle up here is half of the 157. So that's going to be 78.69 degrees. Half of 157.38. So I can find that height. I'm going to call A. That would be a cosine because that's the adjacent side to my angle. Cosine 78.69 equals A over 50. Cross multiplies. That would be cosine 78.69 times 50 divided by 1. 9.81 we'll call it. Down here, I'm going to call this one B. Sine of 78.69 will equal B over 50. Again, we'll make that over 1. What'd you get? Sounds about right. 49.03. Millimeters. That makes the whole distance across here 98.06. So what we have now is we have this piece here of 9.81. We have this piece here of 50. All we need is this piece here, right? We can find that piece off of that triangle. We know this angle is 11.31 degrees. This is a right angle. We do know that side. How do we know that side? Where did I get 14.03? Well, this whole thing is 98.06. I subtracted the 70, you get 28.06, divided that by 2. I need the height. I'll call that F. Tangent of 11.31 equals opposite side, 14.03, over adjacent of F. So we're going to cross multiply 1 times 1403 is 14.03 divided by the tangent of 11.31. 70.15. So 70.15 plus 9.81 plus 50. 129.96 millimeters. Not so bad. How did you have it divided up? It's not 100 across there, though. This isn't the diameter. The diameter would be up here. This is going to be less than 100. That's why we got the 98.06. Oh, sure. And that's a very common mistake, is they look at that. It is very close to the diameter, but it's not quite. Remember, we had that taper problem in like the 3rd week? We had that Morris taper, that ball sitting in the Morris taper, and it was slightly less than the diameter that we had to use. Okay, I have a worksheet I'm going to give you. We're going to be finishing up these complex trig applications here in the next few days. Let me actually just no, we're going to go into 3-dimensional double angle theorems. Yeah, tomorrow we'll have kind of a review of this stuff. Tomorrow's Wednesday already, so Thursday we'll have a quiz, and that'll be the end of it. We'll work on the quiz in class, and then you'll get to take the quiz home for the weekend. And starting next week on Monday, we're going to start double angle, compound angle application. Those would be how to set up a drill press and a mill for milling different surfaces and stuff like that. So I'll give you that worksheet and give you guys the last 18 minutes here to get started.